All right, getting ready for what I would say is your hardest test of your math career. All right. Some of them are easy though. It'll be easy to get a C on this test. Can you solve that? At first, you just want to get the function alone, cosine theta. Get that alone. Then you want to solve for the angle. And then, this is important, and I'm going to say that this is true except for the very end of today's lesson. We're just going to say all of our answers stay between 0 and 2 pi. That means there's pretty much always two answers. Occasionally, there's only one answer if you stay between 0 and 2 pi. For each function. But sometimes we have two functions in a problem. That means you can get two answers for this one and two answers for that one. All right, you should have divided by 2 right off the bat, and then you should have known, okay, I'm going to make my ASTC. I really think having that circle drawn there is smart because sometimes we have to put in the quadrantals, and they are points on the unit circle. In this case, it's not, though. It's where's cosine positive? Well, cosine's positive here and here. And this was supposed to be the slam dunk easy one for you. So, you got two triangles. Figure out what the angles are. Please compare with the kid next to you and see what you think. So, I heard lots of people saying the right answer. Cosine is adjacent over hypotenuse, and that's a square root of 3 there. And then I always put this theta in here, and then I always go across from there and look what's here. And then if that was a 1, it'd be a 30-degree angle. It's not. So then it's the 60-degree angle, the root 3. And then 60 is the same as pi over 3. And then the other answer is a whole bunch of pi over 3s. And I always go here and I go, that's 6 pi over 3, but back off 1, 5 pi over 3. Raise your hand if you had those two answers right. Yay. See, like the beginning part of the test is no big deal. Let's do another one where it should be no big deal. Sine squared minus 2 sine minus 3 equals 0. If you know how to factor, by now, at least part of this problem should be like easy peasy. And until I say otherwise, you can assume I only want two answers. The ones between 0 and 2 pi. At most, two answers for each function. But this is one of the reasons that this test is hard. It's not because of factoring. We did factoring trig before. Even though factoring is a weakness for some of you. It's not this. I think almost everybody's going to figure out that it's well, actually, can this one factor? Nate, what do you think it is? All right, good. Now, so that isn't the trick. That this one, it did factor. Outside and the inside together make negative 2 sine theta. So, yeah. So then what's the trick on this? We'll keep solving, and you'll see there's a trick. There's a nasty little twist. There's the black part, and then there's the blue part. Well, one of these should feel really comfortable, like, yeah, seen that a million times. Addie, what's the one that's weird? Yeah, sine theta equals 3. What's the right answer for that? No solution or undefined. Know why? What's the highest sine can ever go? 1. Remember sine graph? Remember it going like this? And remember the highest it ever went is 1? So when they're asking when is sine equal to 3, it's never equal to 3. The 3 would be like a line up here. They never touch. So that one, does that mean the whole problem has no solutions? No, it just means this part doesn't have any solutions. That's different than solutions that don't work it just doesn't have a solution. I'm fine with just the simple no solution. And I'm also fine with not extraneous, that's different. That's if the answer you got doesn't work. So no solution or undefined. All right, back over to here. This part. Tully, this is a quadrantal. Can you tell me how, if the kid next to you thought that that wasn't a quadrantal, how would you prove to him that it was a quadrantal?
You put the -1 over 1.
I agree.
And like,
What's the thing that makes it impossible to make a triangle here?
that the hypotenuse and the other thing are the exact same.
Yeah, the opposite side and the hypotenuse side cannot be the exact same in a triangle, and therefore it's a quadrantal. Nate, which quadrantal is it? 3 pi over 2 down there, because we want the spot where sine, which is y, is -1, and that's 0, -1, and that's where y is -1. I would say it's y over r. Okay. All of this feeling pretty good so far? This was a little weird, but I think you can handle it. Okay. So, another kind. And in the past, if it just said cosine theta equals 1, you'd be like, oh, draw the triangles, find the spot. But this is different. There's two different ways you could do it. The first step is either this, or the first step is that. But you can't just act like it's not squared and find the answer. That does not work. You have to deal with the squared. Would you talk strategy, please, with the kid next to you? What do you think the first step should be? All right, so I heard two things. I heard square root it, and I heard factor it. And my favorite saying wins. If you can factor it, you should. Here's why. Because if you square root it, you are likely to forget the absolute value thing. A lot of people just go, oh, square root of 1 is 1, so then the square root's just gone. No, you need to do the absolute value of cosine, and that's more complicated, in my opinion, than if we just subtracted 1 and then factored it. Just go with that route. The other way would be legal as long as you don't forget anything, but there's a lot of possible places to forget stuff. Iris, can you factor that for me, please? Yep, there you go. So, quadrantals again. I hope you're getting faster at these. 4 possible spots. Cosine is -1. Why isn't it a triangle? Because the hypotenuse can't be the same as another side. So then this must be x over r. So I'm looking for a spot where x is -1. That's where the spot where x is -1 is, right there. And that's pi. And then we're looking for a spot where the x is 1. And that's that spot. And that's 0, but not degrees. We want to say radians. So the answers are 0 and pi. Raise your hand if you had that one right. Okay, cool. Now watch as I make this problem into a R3 instead of an R2. Like, definitely steps up the difficulty level. Don't like erase this problem. Just watch. What if this was divided by another function? Like, oh, let's see. Let's say that there was something where if the, let me think. Let's say I put sine theta on the bottom underneath it. Now, Would we still want to find the things that make the top 0? Yes, we would. We would still want to figure out what makes this equation equal 0. But by dividing it by sign, that's what makes this one of the hardest tests you've ever had. Well, I'm going to see if I can help you deal with it. So it's got this extra little thing, this extra little sign on the bottom. Do you get that if that part becomes 0, you will be dividing by 0? Remember me talking about how sometimes the answers that you got legitimately can turn into extraneous answers? So, which of these two answers, these two angles, would make the bottom turn into 0 and therefore kill the whole equation, and therefore those must be extraneous answers? Is there one of them that doesn't work, or both of them that don't work? Or just both 0 and pi both happily just still work? So what I'd do is I'd figure out what makes sine theta equal to 0, and I'd make sure that it's not allowed to be. It cannot be equal to 0. Talk to the kid next to you after you think about it a little bit. Which one or both of them do you think don't work? Okay, so I think you guys understand that there's something big about this sign being on the bottom, and that's that it can't be allowed to be 0. So what would make sine equal 0? Well, think of it as its own little problem. If I just had to answer this, what makes sine equal to 0? Well, sine is the y, and which of these have a y equal to 0? This is at 1 comma 0. Does that have a y equal to 0? Yeah. So we can't allow that, because if the bottom becomes 0, the whole thing dies. So that one is not allowed. And what about this spot? Negative 1 comma 0. Does that have a y equal to 0? Yeah, so that spot's also not allowed. So both of these answers, which were good before, both just got thrown out because they were extraneous answers. They would cause the function to actually crash. If you actually stuck 0 in this equation, sure, the top would be 0, but the bottom would also be 0. All right, that's where it gets really tough. Now we're gonna, yes, question?
That can be cut on the test.
That's why I'm talking about it, is because that's the hardest thing. The hardest thing is where there's a function on the bottom and you can't let that be 0. All right, we're gonna go back to a more normal-ish, easy-ish problem. Well, no, I think we're going to do one more of the hard ones, and then I'm going to give you a little mini test, like 3-question test. All right, so here's one more hard one to work out. Cosine theta minus cosine theta sine theta all over sine theta. And that all equals 0. You're going to use my favorite thing. You're going to set things equal to 0. You're going to make sure that you don't have extraneous answers. This is a beast. And honestly, it could have even been worse than this, but this is pretty bad. I'm going to pause for a second. And you should be thinking, what is this favorite thing? Oh yeah, it's factoring. So there must be a factoring involved. Some of you might be tempted to include a tangent in your answer. Don't. Just leave the sign on the bottom. And if some of you think that I can just cancel the sign right off the bat, you can't. Because this would have to be factored first. And if it factored out and you could cancel it, sure, but it doesn't factor. I mean, it factors, but it doesn't factor out a sign. So you cannot just cancel that sign on the bottom. All right, get it factored. Spencer, did you notice there was cosine in both of them?
No.
Pull it out. What'd you get?
Cosine, in parentheses, 1 over sine.
Correct. All over sine theta. Could you make this part equal to 0? Yeah, you could, and that would be smart. Could you make this part equal to 0? Yeah, you could, and that would be smart. Would you then have to watch out for what's on the bottom? Yes, you would. and you maybe figure out that one of those answers, or maybe both of them, get crossed off because they're extraneous. I'm going to pause for a minute. Let you give this a try. Okay, so there was two things to make 0. This needs to be made 0. Cosine of theta needs to equal 0, and that's a quadrantal. It's wherever x is 0. Where is x 0? Is this a spot where x is 0? No, that's a spot where y is 0. Okay, this is a spot. 0, 1. That's a spot where x is 0. So that's one of my answers, pi. And the other one's down here. That's another spot where x is 0. Because that's at 0, -1. And so that's 3 pi over 2. So those two spots are answers. Pi over 2, 3 pi over 2. There's a chance that one of those will get thrown out later, but for right now, those are my answers. This one, where is sine theta equal to 1? That's what makes the top 0. Then sine is like the y. Where is y 0? That's a spot where y is 0. 1, 0, that has a y of 0, yep. -1, 0, that has a y of 0. Oh my gosh. I got all 4 spots. This one's 0. This one's pi. I got 0. I got pi. I said that was pi before. You guys should have told me it was pi over 2. And this says 3 pi over 2. So I have all 4 quadrantals. Holy cow. But wait. Yes.
Sine's supposed to be equal to 1.
Oh, no. Okay. All right. You should have told me that earlier. But yes, you are correct. Thank you. Sine is supposed to be 1, not 0. Sine is supposed to be 1. Because if I put in sine is 1 right here, that'll make the top 0. I got my 1s and 0s mixed up. Okay, so sine is supposed to be 1. So that means y is supposed to be 1, which is here. And I'm going to make sure of that. 0, 1. Yep, that's the spot where y is 1. So that is pi over 2. And sine also, there's only other one spot where y is 1, and that's it. That's the only spot where y is 1. Okay, so my 3 answers then are pi over 2, and 3 pi over 2. So obviously there's really only 2 answers. Now, what makes sine 0 is I go make a whole new problem for that. I say sine theta equals 0 would be bad, so I would want it to not equal 0. So that's where I would figure out what makes sine 0. That's what makes y 0, and that would be this spot and this spot. But I wasn't going to have those answers anyways. 0 and pi, they weren't going to be a problem anyways. So even though there's a denominator here, it didn't throw out, it throw out these two, but I wasn't going to use those anyways. Cool. So it had a denominator, which made me think there was going to be something thrown out, but the 2 things that make that 0 weren't in my list of answers. So my final answer is just pi over 2 and 3 pi over 2. All right. So I'm going to give you 3 problems that I think represent this whole test pretty well. Okay? See if you can handle these questions 3. First one. For cosine squared theta equals 3. Question number 1. I'm going to give myself plenty of room to work. Question number 2. Cosine squared theta minus 4 cosine theta equals 5. And I'm going to give you a minute or 2 to answer those 2 first. And then I'm going to give you the big bad problem. And the last extra challenging one, cosine theta minus cosine squared theta all over sine has to equal 0. Okay, I love that some people, like, they know how big of a deal factoring is, so that they try to factor it, and you subtract 3, but then 4 cosine squared minus 3 is not going to factor. Okay, so good idea, good thought, but no, that kind doesn't factor. So then what do? Well, you try to get the function alone, so then you divide by 4. How many of you knew we were supposed to divide by 4 right there? Okay, good. Next up, I'm going to square root it. And did you remember the absolute value? Because that'll give you twice as many answers. And then square root of this is 2 square roots. Square root of 3 over square root of 4. And the square root of 4 is actually 2. And then that gives me 2 equations. One of them where cosine theta is positive square root of 3 over 2. And one of them where cosine theta is negative root 3 over 2. So then that gives me 2 triangle setups. That'll give me 2 answers, and that'll give me 2 answers. So do you get how that problem had 4 answers? Okay. So the one for this one is cosine is positive here and here. And adjacent is root 3. And hypotenuse is 2. This must be a 1. Across from the 1 is a pi over 6. So 1 pi over 6 and 11 pi over 6. Who had 1 pi over 6 and 11 pi over 6? Okay, awesome. That's for this part. Pi over 6 and 11 pi over 6. And then this part had 2 of its own answers, the places where cosine was negative. So it was over here. And I know they're going to be pi over 6s, so I'm going to save myself some time. It's going to be 5 pi over 6s, and 6 is here, and this must be 7 pi over 6. So 5 pi over 6 and 7 pi over 6. So that's a whole bunch of pi over 6s. There's 4 answers. That's a good, healthy problem. Who got that one right? I need to know. Almost everybody. Way to go. Okay, number 2 was a factoring, and then one part of it makes sense, and the other part of it doesn't make sense. If you factor it to cosine, first I'm going to subtract 5 from both sides. And now it's equal to 0. And then you go cosine minus 5 and cosine plus 1. And now this part won't make any sense, because when is cosine ever equal to 5? Never. So that part's just gone. And then this part, you get cosine... where is cosine negative 1? Because, if this part's negative 1, it'll equal 0. So where's cosine negative 1? It's wherever x is negative 1. And where is x negative 1? Right there. That's where x is negative 1. So therefore this is pi. And therefore that's the answer, is pi. Just one answer. You guys get that one right too? Okay, good. And then the beast. Well, first, cosine is in both of the top parts, so therefore it needs to be factored out. Cosine theta. And then 1 minus cosine theta. And then sine theta on the bottom. And it all equals 0. Well, that's pretty easy, just factoring. Then, when is cosine equal to 0? Because if I make this part equal 0, I get an answer. And I make this part equal to 0, I get an answer. And then I don't want this one to equal 0. So I got 3 things to do. Where is cosine theta equal to 0 for this part? Where is 1 minus cosine theta equal to 0 for that part. And the third thing I gotta figure out is when is sine of theta equal to 0, because I don't want it to be for that part. So then cosine is 0. Cosine is the x in the, whether it is the x0, well that's here and here. That's two places where x is 0. So that's pi over 2 and 3 pi over 2. So far I got two answers. Cosine theta needs to equal +1 at the end. You'd subtract 1 from both sides, divide by -1, and it ends up being cosine equals +1. Think about it. 1 minus 1 would equal 0. So I want cosine to be 1. Where is cosine to be 1? Well, that's like the x is 1. So where is the x1? It's right there. So it's 0. So here's my three answers I got going. Pi over 2, 3 pi over 2, and 0. But then this comes in and says, wait a minute, you better not let sine be 0. Well, sine is the y. Where is y equal to 0? Here and here. Those two answers are thrown out. So do you get that was this one? And you'd have to label it as extraneous. So you got this as an extraneous, not working answer, and these two are the actual answers. Did anybody come all the way to the end on that one? Got all of that right. That's amazing. And then one more thing, the problem would have actually been harder than this. I just didn't want to do it to you because I didn't think anybody'd get it right. What could I have done to make this just a smidge harder? Do you remember that deal where you have the sheet and you're going to have to use the sheet at some point? What if instead of a cosine squared right there, this would have been a 1 minus sine squared right there? Do you get that that could have been there instead of that? And you'd have to swap it out first and then be able to factor it? So there would be one more step that is possible to make this really tough test. All right. So now you've got a review worksheet. It was given to you literally 2 or 3 days ago. At the very beginning of this week, there was a review. I'd like to be specific on where that is. So everybody open up Schoology, please, and find... Can somebody tell me what date the folder says on it that's got the review worksheet? Oh, it's like a big clump folder, isn't it? Monday through Thursday review. Okay, so that Monday through Thursday review folder, in there, there was a thing that said highlighted problems only. Remember that thing? Well, if I were studying for this test, I would do all of the highlighted problems for sure, and then if I wanted some extra ones, I'd go through and do the not highlighted ones. But they're tough. We had you skip them for a reason because those are kind of hard. But there can be stuff like that on the test. None of those are bad problems. So do the highlighted ones because that part I'm going to grade actually affects your grade. Do it. Got the answer key. Not that hard. But really, this is between you and this review packet and taking some serious time. And maybe you want to go back and rewatch this video if you weren't able to completely stay focused during class today. And that's all my last help for you on what could be the hardest test of the year. I think the ones after this aren't this hard. But good luck.